Okay, guys, so I'm going to do this video, K4, and this is we're going to find the integral or the area under the curve of absolute value functions. And what we need to do is split up the integral. So that's why part A here says rewrite the input of the integral as a piecewise function, and then evaluate the integral without a calculator. So that's what we're going to do. First, just a teensy demonstration. So this is the graph of the absolute value of x. It has symmetry, all right, because if you plug in, it doesn't matter if you plug in -1 or 1, the output is going to be +1. It doesn't matter if you plug in -2 or 2, the output is going to be +2, all right? Now, compare that to the graph of y equals x. If you plug in 1, you get 1. If you plug in 2, you get 2. If you plug in 3, you get 3. But with the negative numbers, if you plug in -1, you get -1. You plug in -2, you get -2, etc. So the difference between these two is that for y equals x to become the absolute value of x, you would have to flip this negative part over the x-axis. And you could do that by taking its absolute value, or you could do it by just negating the negative part. If you negate the negative part of a function, it turns it positive, and it does an x-axis reflection. So already we've got that this part of y equals absolute value of x corresponds perfectly with the positive part of y equals x. But then it's the negative part of y equals x that we need to negate if we're going to use this piecewise thing. All right, so the absolute value of x, we can write this as a piecewise function in two parts. If I want to flip this negative part over, I can do it by negating it. All right, so I want to express my function. So now if I do that, then this part completely aligns with that part. All right, so the way I can write this absolute value of x as a piecewise function with two pieces is I say that it is negative x, that it's negative x on the interval from, let's say for x is less than or equal to 0, and then it's regular x for x is greater than 0. Now guys, the less than or equal could be on either of these, but it can't be on both. Okay, so you just negate the negative part and that flips it. All right, so now that's what we're going to do. So we're going to take this input. So we're going to take the input of the integral, absolute value of x minus 4. Then we're going to take its input, which is just x minus 4, and set it equal to 0. And then we get x equals 4. Then I'm going to do a number line. This number line is talking about values of x minus 4, not the absolute value, the input of the absolute value, so x minus 4. And then I put 4 on this number line. I pick a number to the left of 4, I plug it in here, like 0. I get a negative number. So on this interval to the left of 4, x minus 4 is negative. It's below the x-axis. To the right of 4, pick like 5, plug it in there. You get positive. So to the right of 4, this x minus 4 is above the x-axis. So to write this as a piecewise function, you have to take the negative, on the negative interval, you need to negate the input of the absolute value because that's going to flip it over the x-axis. So negative x minus 4 for x is less than or equal to 4. and then just regular x minus 4 for x is greater than 4. Okay, so negating this on the interval where it's negative makes it positive. All right, so, all right, so let me simplify this a little bit by distributing. So this is negative x plus 4 for x is less than or equal to 4. X minus 4 for x is greater than 4. All right, so that was part A. Now part B. Yep, so this is part A. Now part B, evaluate the integral without a calculator. Okay, so it goes like this, guys. We've got to split this up. So 4 is the endpoint. It's where one part of the piecewise function begins and where the other one ends. So, and 4 is in the middle. It's in between -3 and 8. So I'm going to split this integral up. I'm going to have one integral from -3 to 4, and then another integral from 4 to 8. Okay, so this is equal to the integral from -3 to 4. Now on this interval, -3 to 4, if you look at this piecewise function, we're using this piece. So inside I'm putting -x plus 4 dx plus the integral from 4 to 8. On this interval 4 to 8, we're using this one, x minus 4 dx. They say without a calculator, guys, that means the fundamental theorem of calculus. So I'm opening up some brackets here, -3, 4 plus brackets 4, 8. The antiderivative goes in here. So the antiderivative of -x is -1/2 x squared plus 4x. And then over here, it's like the same thing, but different signs. Okay. Now we gotta plug 4 in. So -1/2 4 squared plus 4 times 4 minus -1/2 -3 squared plus 4 times -3. All right, that plus comes down. I'll try to write small. This is 1/2 8 squared minus 4 times 8 minus, oh boy. All right, in those parentheses, it's going to be 1/2 4 squared minus 4 times 4. Okay. Alrighty, so this is 16, all right, that's -8 plus 16. This ends up being -9/2. So distributing the negative plus 9/2. This is -12. So plus 12. Plus 8 squared is 64 divided by 2 is 32. Minus, 4 times 8 is 32. And then this is minus 1/2 4 squared is 8. And then this is -16. So, and we distribute the negative, so plus 16. All right, now it says without a calculator, but at this point, guys, we're just basically practicing up to this point without a calculator. If something like this were on the AP exam, or there wouldn't be something with this much arithmetic. So I'm using a calculator right now. Plus 12 plus 32 minus 32 minus 8 plus 16. Oh boy, I got 32.5. Let me go like this. I got 32.5. Now I'm going to check this using Math 9. Please work. Math 9. So from -3 to 8. and then math x minus 4. Yes, okay. This 0.5000, it's okay. The calculator is just, you know, I don't know why. We could ask someone who's good at computer programming, but if it's this, if the calculator gives you this when you use Math 9, it's 32.5 exact. I don't know why that happens. Okay, now we're going to do this one. And guys, I want to review trig just a little bit. Okay, right here. A little bit of trig review. This is the unit circle. It has radius 1. Cosine of theta is x, sine of theta is y. Now, so these points here, this point is 1, 0. This point is 0, 1. This point is negative 1, 0. This point is 0, negative 1. So cosine of theta equals 0. So when is the x-coordinate equal to 0? It's when, so theta needs to be the angle that brings you to an x-coordinate, to a point with an x-coordinate of 0. So pi over 2. And then this one down here would be 3 pi over 2. 1, 2, 3 pi over 2. All right, now sine of theta equals 0 when? Sine is the y-coordinate. So at these 2 points, we've got y-coordinates of 0. So theta equals 0, like if you don't move at all. So a rotation of 0 would bring you here. A rotation of pi would bring you here. And then this is a little redundant, but if you go back around to 2 pi, that would also give you a sine value of 0. Okay, so we're going to do this. Same idea. So this time we're taking the absolute value of sine, and then we're taking its input out. We're setting it equal to 0. And guys, I really just kind of said this. So if sine of x is 0, then that means that you know, these numbers here. Okay, 0 pi, 2 pi. Now guys, we're only looking here at pi over 2 to 2 pi. So I guess I'll just say, oh yeah. So it's only the number within this interval really that we care about, I guess. So theta equals 0. 2 pi. All right, I guess I'll use all of them. Theta, so x equals 0, x equals pi, x equals 2 pi. All right, then I do a little number line. This number line is for sine of x. Okay, I can put, yeah, I'm only going to look at one rotation. So I guess I'll start here at 0, pi, and then 2 pi. And then guys, when you're figuring out if sine is positive or negative, I would just do a circle like this and put these points on the circle. So here's 0 or 2 pi, and then here's pi. Guys, sine is the y-coordinate. From 0 to 2 pi, is sine positive or negative? Or from 0 to pi. Yeah, from 0 to pi, sine is positive. Then from pi to 2 pi, sine is negative. Okay? So, this absolute value, this absolute value of sine is going to be equal to, on the positive interval, I'm keeping it. So it's going to be equal to sine of x on, let's say 0 is less than or equal to x is less than pi. And then it's going to be equal to negative sine of x from pi is less than or equal to x is less than or equal to 2 pi. Okay. Yeah, and now I'll go over here. So this is equal to the integral from pi over 2. So pi over 2 is here, guys. All right, so pi over 2 is here. So it's in pi is the cutoff, really. Pi is where the first one stops and the second one starts. Okay, so pi is the cutoff. So from pi over 2 to pi, I'm going to use regular sine of x. Plus, from pi to 2 pi, I'm going to use negative sine of x. Okay, now we're doing the fundamental theorem. Pi over 2 pi plus, oh, no. Pi to pi. Okay, the antiderivative of sine is negative cosine. The antiderivative of negative sine is regular cosine. So this is going to be negative cosine of pi minus negative cosine of pi over 2 plus cosine of 2 pi minus cosine of pi. All right. Now, guys, you've got to be thinking in terms of like this right now. Cosine of pi is -1, so that's -1. Cosine of pi over 2 is 0. Cosine of 2 pi is +1. Cosine of pi is -1. So this is 1 plus 1 plus 1. That's 3. Okay, let me do a little check. So I need to be in radians, and I am. Math 9. Pi over 2 pi. Math, absolute value, sine of x. Please be 3. Yes. Okay, so same deal with the zeros, but it's 3. Okay, guys.